Okay, so now we're going to prove the second derivative test, which basically says that, excuse me, if you have that the first derivative is 0 at some c, and you also have that the second derivative is positive, then you'll know that this c value is a local minimum. Basically, the way to do this is to start off with the definition of derivative. I mean, your intuition is there. You have that the second derivative, right, it's positive, so it's concave up. Therefore, where the first derivative is 0, this point right here is definitely a local min. But okay, that's just your intuition in the graph. But the way to do it is to use the definition of a derivative here. So the second derivative at c is equal to the limit as h goes to 0, the first derivative of c plus h minus the derivative of c over h. And that's just the derivative, that's just the definition of the second derivative. Now we have some facts that we could fill this in about. First thing is that this is positive. Then the next thing is that f prime of c is 0. So this whole limit becomes the limit as h goes to 0 of f prime of c plus h over h. And given the fact that this is going to be greater than 0, right? You know that the left-hand limit has to equal the right-hand limit, but you also know that then this thing, right, this whole thing, for values that are to the left of c, right? So what are the choices for c? Let's look at this, and let's look at this here. Let's say here's c, right? If you come to 0, but from beneath 0, you have that c plus h is over here, right? So it's to the left of c. And the bottom will be negative because h is negative, right? So for negative values of h, it has to be that then this is also negative in order to maintain that it's greater than 0. So when I'm to the left of c, f prime is positive. This implies that when just directly to the left, directly to left of c, we have f prime. Oh, I said f prime positive? No, f prime negative. Okay? And that means that f is decreasing by the first derivative test on left of c. And by similar logic, right, using this, if I say imagine h being positive, right, then that means that we have values over here, and then that forces this value to be positive. So when directly to the right, right? When we're directly to the right, these values over here of c, we have that the first derivative is positive, which implies f is increasing to the left, I should say, to left to right of c. And these two things together imply that at c is a minimum. What's happening over here? It's decreasing, decreasing. This is f that I'm sketching, right? I just said that directly to the left of c, f is decreasing, right? So directly to the left, it's decreasing. And then after that, it's increasing. So from this, right, f is increasing directly to the right. These two together imply that c is local min. And you're done.